and man with a very soft heart, always helping. And immediately after the Gujarat earthquake, he and his team had cut short all their business work, and they were helping out in Gujarat on a systematic rescue operation of people. He is a member of almost all the professional bodies across India. Presently, he is senior advisor to the new technologies for construction, and he is a founder member of the BMS SMRC Structural Masonry Resource Center based at BMS College of Engineering. Man always in a hurry. He loves cycling. I don't know how does this matches with his speed, but he loves cycling. Any time in the day, you call him, second ring, he picks up the phone. He is into trekking, a magician who would always sensitize to children with his magic tricks. His reading includes economics, neurosciences, and human psychology. This is the last one I did not know about Ashok. Today, Ashok will be speaking on the latest technology on interlocking concrete block masonry. I request Professor Bharti Ganesh to kindly hand over him a bouquet and welcome him.
Hello, can you hear me? Thank you, Rajesh. That was a very nice introduction. Normally, I'm known as a concrete surgeon, a man who cuts concrete. But lately, I have decided that as I grow older and more mature, instead of doing more destructive work, I want to be more constructive. So I'm turning all my energy into construction activity. And my latest love is masonry. Today, I'm going to talk about new technology. This is dry, stackable, interlocking, hollow block masonry. The dry stackable masonry. This is actually brought in by one of my friends into India. Actually, I wanted to bring it in, and I had gone to Australia. I went there, I found out, they told me that another gentleman from India had come in already. And I asked him who, and I found out that one of my very, very good friends. So I called him up from there, and he says, hey, I brought it in before you. Okay. Anyway, so now I'll just present this. I don't represent his company or anything, but it's a very interesting technology that I thought that we should all know about. And this is one of the technologies which I would predict would be very, very helpful in the coming 3 to 6 years in our country, because we are having a lot of trouble in finding skilled labor to do jobs. And I believe that we cannot go back to the old system where we set up training schools for masons, carpenters, because technology itself has to change. Today, a mason's son does not want to become a mason. A carpenter's son does not want to become a carpenter. So there's no point in setting up training schools for skilled people, because they just won't do it. So we need to pay them twice, but at the same time, to be in business, we have to see that their productivity increases 4 times. That way both of us benefit. So how do we do that? We do that by changing technology itself, the technology of building. So that's what I'm going to present to you today. It's a very brief presentation, because I'm not the originator of this technology. I'm just taking this technology and showcasing it, and you can always correspond with these people to know more. This will be a very short lecture. Thank you. I'm going to play a small video now that will tell you most of it. This is the block making machine which manufactures the blocks. Just a little patience. Once that's over, then we'll see how the blocks are being laid. These are the blocks. The typical block size is 400 mm by 200 mm by 200 mm. These are the blocks. Now you see how they are going to be laid. The first course is very important. You have to lay it perfectly, and after that it's as simple as stacking Lego blocks. They are interlocking, so all you have to do is just place it one on top of the other. Well, because they are hollow, you can insert vertical steel, and before you lay the next course, you can always insert horizontal steel. And this is called a form bridge. It's a bridge which helps to interlock adjoining blocks because it can be stacked up to about 4 meters, and then concrete can be poured inside. So this will work as permanent shuttering. The slots there inside the bridge are there for us to place reinforcing rods. You can see that the surface is very well finished on the outside and the inside. This is how you lay horizontal reinforcement, and at the corner. The slots in the form bridge hold the reinforcement in position so that it gets locked and doesn't move. The small wedges are given which can be inserted in case we want to maintain the plumb of the rod. Very simple process of erection, very less skill required. All that we need to do is check the plumb and the plainness. That's all we need to check. Simple instrument, and laying this block can be taught to anybody within a day. And as you can see, the work is extremely fast. Incidentally, Australia is home to a number of such labor saving technologies. The reason being, labor is extremely expensive in Australia. And when I say expensive, skilled worker in Australia would earn typically about $80,000 to $120,000 per annum, Australian dollars. So that is the kind of money that they pay, and therefore Australians are very focused on using technology to reduce labor, so that when they want to do the job, they engage very less labor. Typically on a building you will find some 3 or only 4 people, or maximum only 6 people who do the job. You don't find many people, just can't find them. They're too expensive. Nobody can afford them. So once the blocks are laid and the steel is inserted, you pour concrete into the block and it becomes a concrete wall. So this whole thing is designed as a combination of masonry and shear wall. Typically what is put inside is M20 concrete or M25 concrete. Blocks are extremely good, and sometimes some grout comes out, but most of it actually remains inside. Blocks are very well made. Okay. So you just saw the video, you must have understood most of it. I'll just run quickly through a few more slides. I just talked about this. There are 3 types of blocks. The standard block, there's a uni block or a U block, and then the half form block. So that's why you can put in vertical steel, the standing position, and then you can also put horizontal steel as you just saw. Here are some shots on site. Training is very simple. This is a shot of a form block. It is filled with concrete, and then the wall is cut to show how the grout fills in from inside the cross section. A lot of tests have been conducted by this company in New Zealand and at Auckland University. It complies with the various masonry codes. You can see that the flexibility test is also done like this. It can take up to 4 meters height of wet concrete poured into it. This is a U-block beam. So what is done is the U-blocks are placed over there, and then steel reinforcement is put inside and it is concreted. So there is no separate reinforced shuttering required to make the beam. This is the kind of finish that you typically get. Very beautiful finish. This is one more example. Actually, this is a very interesting shot. These people had gone to Dubai to get certification for their masonry wall system, and then they were having a tough time getting the documentation done. And then suddenly the project manager had a brilliant idea. So what he did was he actually built the wall, and then he raised it by a crane like this. The next day they were granted the certification for earthquake resistance and for all the other tests that could be passed. This is the project in Dubai. It's called a Motown City, where they wanted curved walls, so the curvature could be adjusted with this. The retaining wall. This is that uptown Motor City, which was a very large project, and they were using 500 men and 300 mm thick blocks. By using this form block, they replaced it with 200 mm form block with a workforce of just 50 men. So 1/10 of the number of people were then required to complete the project. You can see that the site is very, very clean, because more a matter of erection rather than actual construction. This is a project in Australia and I think New Zealand where they have used form block. We can design up to ground plus 12 very easily with this load bearing structure. This is a ground plus 12 story structure in Melbourne. This is a project which has been started in Lavazza. This one sample project that has been started for a temple in Lavazza. That was the first project in India. This is a project in Bhopal where they are going to use it for a factory project. They have already started using it, building the factory. Lavazza, they have an initial contract of 14 buildings, G plus 5 stories, and the foundation is using strip footing. Lodha has granted them a G plus 7 story project has been planned. This is going to be started very shortly. This is the kind of modular planning that is being done for the Lavazza project, ground plus 5. I don't want to get into further structural details. This is the block which is used to produce that form block. A simple machinery is used and the block can be prepared quite easily. So, to sum up, form block is a mortarless masonry structural block system. It is not a non-load bearing system, it's a load bearing system. It's a very trainable system, so the system can be easily used by local labor with very minimal training. It can be designed as structural masonry to support ground plus 12 stories and saves on time, labor, steel, cement, formwork and scaffolding. So that's my lecture, as fast as form block can be laid. Thank you very much. In fact, I was having some difficulty. I was telling everybody that we have overshot time, and then I was told by Nagesh then it's your responsibility to see that you cut down on the time. I followed your instruction again. Thank you very much.
Thank you, Ashok. That was a wonderful way of presenting a new technology. I would now request Dr. R. Nagendra from Civil Aid Techno Clinic to kindly hand over a memento to NR Ashok.